This video introduces us to angle pair relationships. One of the first things that we need to know about angle pair relationships is one of the first types of angle relationships are adjacent angles. Adjacent angles are two coplanar angles with a common vertex and a common side. But the side has to be on the interior. So angle 1 is adjacent to angle 2 and angle 3 is adjacent to angle 4. Okay, but if I have letters and I have angle A, B, C, and let's say angle 1 is inside of angle ABC, it is not adjacent to it. Adjacent is right next to it. The first type of angle relationship we have is complementary angles. And complementary angles are two angles whose measures have a sum of 90 degrees. Each of the angles is called a complement. So 40 and 50 are complementary angles, but 40 is a complement to 50. We also have perpendicular lines, and those are lines that intersect to form 90-degree angles, shown by the little box here or the upside-down T symbol. So we have two types of complementary angles. We have adjacent complementary angles, where the angles are next to each other, they are touching. We know they are complementary because they have this right angle symbol letting us know it's 90 degrees, or it's going to tell us, or ray AB is perpendicular to ray BC. So we can either see it in the picture or it will tell us using the perpendicular symbol. And what that means is that the measure of angle ABD plus the measure of angle DBC is equal to 90 degrees. We don't know what these angles are, but we know their sum is 90. We can also have non-adjacent complementary angles. So in this case, we have angle D and we have angle E, and angle D is 23 degrees and angle E is 67 degrees, and when I add them up, that tells me that they are 90 degrees, and that means that they are complementary to one another. So they don't have to be touching, but there needs to be some way to prove that they're 90 degrees. So by adding them together, that lets me know that they are complementary. So if I look at these examples, if I want to solve for x, well, the directions, which you always have to read, are telling us that ray EF is perpendicular to ray FG. And there's already a right angle symbol there. I always like to stress it and go over it to remind myself, and it wants us to solve for x. So again, there's plenty of work to show. 7x plus 2x is equal to 90. I know it's equal to 90 degrees because perpendicular rays form 90-degree angles. And now it's just a matter of solving algebraically. So therefore x is equal to 10. Another example says that angle A and angle B are complementary of each other if the measure of angle A is 3x and the measure of angle B is 15, solve for x. Well, if they're complementary, that means they add up to 90. So the measure of angle A plus the measure of angle B is equal to 90. And now I just substitute. Angle A is 3x, angle B is 15. And once I set up my equation, now I just solve it algebraically. So when people tell me that there's no work to show, this is the work that I want you to show. Now, in addition to complementary angles, we have what are known as supplementary angles. And supplementary angles are two angles whose measures have a sum of 180 degrees. Each angle is called the supplement of the other. So there are, again, two types of supplementary angles. Adjacent supplementary angles that look like they form a straight angle or a line, and non-adjacent supplementary angles. That means they are not touching, but their sum is still 180 degrees. So now here is one example. Two supplementary angles are in a 1:3 ratio. What is the measure of the obtuse angle? So if it's in a 1:3 ratio, that means that it's 1x plus 3x equals 180 degrees. So 4x's equal 180, x is equal to 45, but it wants to know the measure of the obtuse angle. So the 3x is going to be obtuse because 3 is bigger than 1, so therefore it's obtuse. And 3 times 45, which means that the obtuse angle is equal to 135 degrees. Supplementary angles lead us to our next postulate, which is the linear pair postulate. The linear pair postulate states that two adjacent angles form a straight angle, or it has 180 degrees. So, if two angles form a linear pair, then we automatically know that they are supplementary. So that means if I look at this and I see, hey, that's a linear pair, they're adjacent and they form a line, that automatically lets me know that their sum is 180 degrees. So if I look at example 4, it says, find the measure of angle GHJ and angle JHI. So these form a linear pair because they are adjacent and they form a straight angle. So I would say that 3x plus 4 plus 13x is equal to 180. And then I just solve this algebraically. And x is equal to 11. But then I always want to go back up and make sure, because I want to make sure I have what I'm looking for, and I am looking for the measure of angle GHJ, and GHJ is 3x plus 4, so that would be 3 times 11 plus 4, so that is going to be 37 degrees. And the measure of angle JHI is 13 times 11, and that is going to be 143 degrees. Please try this example. Because they form a linear pair, we can set them equal to 180, solve for x, and substitute. The next term that we are going to learn is vertical angles. And vertical angles are formed by a pair of intersecting lines. If we look at this and I say that angle 3 is, let's say, 150 degrees. Angles 3 and 2 form a linear pair, so I know they add up to 180 degrees, which lets me know that angle 2 is going to be 30 degrees. And then, if I look at it this way, angle 2 and angle 4 form a linear pair, which means angle 4 is going to be 150. And then again, if I look at it this way, angle 1 and 4 form a linear pair, or angles 1 and 3 form a linear pair, and angle 1 is going to be 30 degrees. That lets me know that these angles are congruent. So what you need to know is that vertical angles are congruent. The measure of angle 1 is equal to the measure of angle 2, and the measure of angle 3 is equal to the measure of angle 4. They will not always be so obvious, and they could be turned, but what you need to know in vertical angles is that opposite angles are congruent. And congruent is an equal sign with a little enye on top of it. And opposite angles are congruent, but they must share a vertex. So if we look at number 6, we know that the measure of angle 1 is 52 degrees, and we want to find the measure of angle 2, the measure of angle 3, and the measure of angle 4. So I start with the easiest one. If angle 1 is 52, the angle opposite, in this case 3, is also 52 degrees. And to find the measure of angles 2 and 4, I would take 180 and subtract 52 because it's a linear pair. So I get 128 is the measure of angle 2. And if I know the measure of angle 2, then I know the measure of angle 4. In this case, for number 7, I want to find the measures of angles AEB and BEC. So if we look at this, one has to say, well, why can't I just add these up and set it equal to 180? Well, this has a y and this has an x, so I'm going to use opposite angles. I'm going to say that 4y minus 64 is equal to y plus 17 because they are opposites. They are vertical and they are opposite each other. So 3y is going to equal 81, and y therefore is equal to 27, which means that the measure of angle AEB is going to be 4 times 27 minus 64, which gives us 44 degrees. Your job is to find x and the measure of angle BEC. Please make sure to bring any questions you have to class.